Shake Table Lab by Kupose and Ethan Farah. These were the original sketches of our building. Many of its features are shaped off of these core models, but we made our tower 84.5 centimeters tall rather than 37, but other than that, these sketches are fairly accurate. When the construction of our building had first started, Ethan and I secured the base and finished the strong outside supports. The outside supports were one of the most important parts of our building. Just a little bit into our construction, we had finished the crosses on the ceiling of the first and second layers and all of the walls. Ethan and I did this to add supports to all parts of our building. Our tower looked like this after the first and second stories of our tower were completely finished with construction paper floors. All we had left to do was the third story and the tower on the top. Finally, Ethan and I finished our building with the shorter third story and the very tall tower on the top of it. We added a pendulum in the Illuminati tower on the top because it might give our tall tower extra stability. This sketch has all of our building's dimensions labeled. Our building turned out a lot differently than planned, as its total height is a staggering 84.5 centimeters versus our originally conceived 37 centimeters. Static testing of our building proved to us that it could easily handle 4 sandbags. This test made us more confident that our structure could withstand several sandbags in an earthquake. These arrows are pointing to some of the strengthened parts of our tower. On the middle right, we have one of our double-thick supports, which is one of the most supportive parts. On the bottom right, we have a sturdy joint of several straws, and on the left, we have a strengthening bond of a cross support. Our structure's bottom layer has many strong and sturdy parts that support it. Double supports on the outsides are the frame of our building, and we have attached straws underneath the cardboard base to ensure that it stays in the same place throughout the earthquake. There are also cross supports, which strengthen each layer because triangles are the most sturdy shapes. The third story of the building is one of the weakest parts. Ethan and I did not make much support up here because it only has to support the Illuminati tower on the top, which is relatively light. Strength is lacking here mainly because we only have single straw supports on the outsides. Tape is what holds the joints of our building together, so it is definitely an important part. Each joint is attached with a good amount of tape to ensure that our structure will not fall apart during an earthquake. Some extra supplies that Ethan and I received to enhance our building included construction paper to use as flooring. We put the paper in to ensure that the sandbags would have a place to rest and would not fall through our structure during an earthquake. We kept adding sandbags to our tower to see how much it could hold.
Why you gotta be so rude? Seriously, it just let me know.
Our tower collapsed at 16 sandbags. This graph shows the side-to-side motion, up and down motion, and front-to-back motion of our tower as recorded by a sensor on the first floor. The Z on the top of the graph is the up and down motion, the Y in the middle of the graph is the front-to-back motion, and the X on the bottom of the graph is the side-to-side motion. My building held 14 sandbags. It failed at the bottom story because the pendulum we put at the top of the tower to keep it steady actually made the building top-heavy and sway too much, which caused our bottom supports to collapse. If I redid this project, I would take out the pendulum and make our building structure come in more to make a sturdy base that would hopefully support our building entirely. I learned that if you are building an earthquake-proof building, you want to put as many triangle supports on the bottom foundations as possible. Refrain from making your building too tall, and make sure that it has a wide, steady base. What I enjoyed about the Shake Table Lab was working with my friend Ethan and being given the opportunity to create something that was creative and imaginative, but that would still go to use. The Shake Table Lab was a great experience for me.
Our tower supported the weight of 14 250-gram weights, evenly spread out on the first and second floors. At 16 sandbags, our tower could not stand. It collapsed in complete mayhem and chaotic destruction. The Illuminati tower failed at midpoints of the ground supports and at the central pole. Although we had strengthened these parts, the weight of 16 sandbags was too much. This led to the tower's utter destruction. Also, the pendulum that we attempted to build at the top did not sway correctly against the swing of the tower. So instead, it swung with it and led to swaying the tower off balance. The most important changes that we could have made to this tower was to make it bend in farther, and also to add one more straw to each crossbeam. By making the tower lean in farther, we would make the weight be more evenly spread out and more absorbed. By adding one more straw to the X supports, I would help by adding more triangles, since triangles are the strongest of all polygons. By having one X and adding one more straw going straight down, that would give us 6 triangles versus 4. I learned that to create a sturdy building that would be earthquake-proof, you have to only take into account not the materials used, but the arrangement of those materials. For example, I learned that cross supports in the shape of an X are much stronger than cross supports in the shape of a V, because X's give you 4 triangles versus V's giving you 3. Also, I learned that to use as many triangles as possible, since that is what would help the building be sturdy. I enjoyed literally everything about this project. My favorite part of this project was definitely building with my partner Cooper. I also enjoyed building our roof and pendulum. I could express my creativity and also do something out of the box with my partner. And this was one of my best experiences in 6th grade science class.